Hi everyone, this is lecture 3.1, higher order derivatives, velocity, and acceleration. We know that the function y equals to f of x have a first derivative of y equals to f prime x and a second derivative of f double prime x. Let's take a look at example 1 from Learning Resources. Find the second derivative of y equals to 4x cubed plus 2x. In this case, what we have to do is we have to first find the first derivative, which is f prime x, and then from that we have to take the derivative again in order to find f double prime x. So the first derivative will be 12x squared plus 2, because we use 3 times 4, that's 12, 3 minus 1, that's 2, plus the derivative of 2x is 2. Now if we take the derivative of f prime again, then we get the second derivative, which is going to be 24x. Let's take a look at example 2. Determine the second derivative of f of x equals to x over 1 plus x when x is equal to 0. Well, first we have to determine what f prime x is. And when we organize our solution, that's going to be 1 over x plus 1 minus x over, in bracket, x plus 1 squared. Which is the same thing as 1 over x plus 1 squared. And it can also be written as, in bracket, x plus 1, bracket close, to the exponent of negative 2. From then, we can calculate the second derivative of f of x, and that will be negative 2 times x minus 1 to the power of negative 3 times the derivative of whatever inside, and that's going to be 1. It can also be written as negative 2 over x plus 1 to the power of 3. We're supposed to find the second derivative of f of x such that x is equal to 0, so we plug x is equal to 0 back into this equation, and we get negative 2. Now let's take a look at motion on a straight line. The first derivative of s of t, keeping in mind that s of t is the distance with respect to time, that would be v of t, which is the speed with respect to time. The second derivative of s of t will be a of t being the acceleration with respect to time. The absolute value of velocity is called speed. Now let's take a look at example 4 from the Learning Resources. A football is kicked vertically upward. The position, s of t, in meters, of the ball above the ground is s of t equals to negative 5t squared plus 30t plus 1, where t is in seconds. Determine the maximum height reached by the ball. Our strategy for solving this is first we have to solve for the derivative of s of t, and that's going to be v of t. Then we have to make v of t equal to 0, because when v of t is equal to 0, then we get a horizontal tangent. So the derivative of s of t is negative 10t plus 30. We make that equal to 0 and solve for t. T will be then equal to 3. We know that when time is equal to 3 seconds, the ball is at maximum height. But we want to know the maximum height in meters. What we do is we plug this value of t equals to 3 back into the original equation of s of t, which is the distance with respect to time. And that's going to give us s of 3 is equal to negative 5 times 3 squared plus 30 times 3 plus 1 equals to 46. Therefore, the maximum height reached by the ball is 46 meters. Now determine the velocity of the ball when it is caught 1 meter above the ground. 1 meter above the ground means that s of t, which is the distance with respect to time, is equal to 1. We know that s of t equals to negative 5 times t squared plus 30t plus 1. We minus 1 on both sides and solve for t. T can either be 0 or t can be 6. We know that t cannot be equal to 0 because when t is equal to 0, this is actually the time when the player throws the ball, not catching it. So we know that when the player catches ball, t equals to 6 seconds. So we plug t is equal to 6 into the equation for v of t, which is the speed, and solve for the speed, which will be equal to negative 30. Therefore, the velocity of the ball when it is 1 meter above the ground is negative 30 meters per second. And that's the end of this lecture. Thank you guys for watching.